Hi guys, welcome to one more session of UPSC Basics. And in geography today, we will be covering Earth's movement, that is rotation and revolution both, mathematical location of places, that is by latitude and longitude, and the standard time and time zones. Okay, so today it will be more interesting because we will be having more dynamic concepts coming. So let's see first the rotation of the Earth. So in rotation, you know the Earth has an axis. Okay. The topmost point is North Pole and southmost point is South Pole, and the Earth rotates around it. So let's assume this ball is Earth, and I hope you can see the line there. Okay, so that's the equator. This North Pole is the South Pole, so Earth rotates in this way. Okay, that is from west to east. So because of this movement of the Earth, that is rotation, we experience day and night. Okay, the phenomenon of day and night. So one more thing is dawn and twilight. Okay, so dawn is basically the very short period from sunrise to complete daylight. Okay, so what happens is early in the morning when you see orange in the sky, right? It's not complete blue. So that whatever you're experiencing is dawn, DAWN. It's not DON. And twilight is similarly that happens in the evening. The short period from sunset to complete darkness is twilight. Okay, the reason is Earth is like this, right? So imagine sun's rays are falling from here. So the face, so from here, whatever we are seeing is facing daylight, right? Because it's experiencing daylight. So the one which is on my side now is experiencing night. But the region which comes here on the borderline, the rays actually are slanting here, right? So because of the refraction of light, what happens is they see different color. Okay, they see orange, red, right? And then when they reach here, say suppose this is the borderline, they reach here and they are now facing the sun, they get the complete daylight experience. Same is the case here during sunset. Okay, so that is twilight. The one experiencing sunrise, that is known as dawn.
So after we are done with the rotation of the Earth, let's see revolution of the Earth. So here, as you can see clearly in this image, you can see that the orbit on which the Earth rotates is ellipse in shape. It's not completely circular in shape. Okay, so the shortest distance from the Sun is on 21st of March and 21st of September. And these 2 days are known as equinoxes. Okay, obviously reason being day and night are same. Okay, the length of day and length of night are same on these 2 days. Secondly, you have 21st of June on the left and 22nd of December on the right. So these 2 days are known as solstice. Okay, and secondly, when we refer to these, so that is June solstice, you have September equinox, 22nd of December, that is December solstice, and March equinox. They are also known as, the March one is known as spring equinox. Okay, the 21st of June is known as summer solstice. The 21st of March or 21st of September is also known as autumn equinox, and 22nd of December is known as winter solstice. Now I'll tell you the reason. All these are set according to the northern hemisphere. Okay, so 21st of March is spring, right? It's pleasant. In northern hemisphere we also experience the same. 21st of June is known as summer solstice. Reason being, on the tropic of Cancer, that time the rays of sun fall perpendicular on the tropic of Cancer, right? So what happens is there it is extremely hot. Okay, then you have autumn in September and you have winter in December. Okay, so this is how the revolution works. The speed at which Earth spins around its orbit is 18.5 miles per second. Okay, that's too fast, or in miles per hour I would say 66,600 miles per hour. And to complete one rotation, it obviously takes 365.5 days. Okay, so every time it is not possible to count the half day, right? 1/4 day, right? So that 1/4 day is considered as 1 day after every 4 years, which we call as a leap year. Okay, so completing one revolution, it takes 365 and 1/4 days. So what are the consequences of it? Okay, so what do we experience out of it? First thing is varying lengths of day and night. Obviously, when the distance is more from the sun, we experience more night, and obviously when it's close, that is, we experience the length of day being more. Secondly, seasonal changes, obviously, and their effects on the temperature, that is very obvious. Now the next concept which comes is mathematical location of places on the globe. So how can you mathematically locate any place on the globe? So obviously what geographers came up is by locating it by a coordinate system, like, okay, so what they did is they made parallel lines from the north pole to south pole, which are known as latitudes, and vertical lines which are known as longitudes. Okay, so the latitudes being from north to south, you have 90 degrees till north, so 90 degrees north is the north pole, 90 degrees south is the south pole, and on the equator you have the 0 degree. Okay, it is neither 0 degree north or 0 degree south, it is known as 0 degree only. Secondly, for vertical location you have longitudes. Okay, so these longitudes again from north to south, and from the prime meridian which passes through Greenwich. Okay, that is the reason we say Greenwich Mean Time, and the line which passes through Greenwich is 0 degrees. Again, it is 180 degree in the east and 180 degree in the west. Okay, so this just gives a basic idea how we could mathematically locate any place on the globe. So this is how the latitudes were formed. Okay, so what they did is, if you cut our globe in the center and the equator considering as 0, so wherever you get the center point and you draw angles on it, okay, wherever the angles touch on the surface, okay, the external surface, you just go on drawing parallel lines like they have done here, right? And obviously the northern pole that is the reason why the northern pole is 90 degrees north and 90 degrees south. Okay, I hope this is very clear, because this diagram makes a very clear image of how latitudes were drawn. Secondly, since the north pole, the poles are flattened a bit like an apple, like an orange. Okay, so that is the reason why you have more dense number of latitudes towards the poles, and towards the equator they are quite rare. Okay, the spatial distribution I'm talking about it. And what happened is, these degrees, they didn't surface the exact location. So 1 degree was again divided in 60 parts and known as 60 minutes. So every 1/60th part of a degree is 1 minute. Again, the minutes, again, it was covering a big area, very big area. So again, for that 1 minute again was divided in 60 parts and known as seconds. Okay, so division again, 1 degree is divided in 60 parts. Each part is known as a minute, and every minute is again divided in 60 parts, and each of the part is known as a second. So now let's see how the longitudes were formed. And again, as I told you, from the prime meridian, if we cut the globe, as you can see here, right, and from the prime meridian, again from the center you draw lines. Okay, but this time not on the equator, this time from on the equator. Okay, last time from the equator we drew, this time it's on the equator, and the way the angles are formed, okay, you can see here on the left hand side they have shown the cut section. So likewise the longitudes were formed. Okay, and it divides the world into different segments, obviously. So now the next concept is standard time and time zones. Okay, so what happens is, let's imagine today is 12 noon right now going here, and in America it's 12 at night. 1 minute from now would be 12 past 1, and same would be the case there. But today, whatever it is, let's assume it is 20th today. Okay, so today if it is 20th, 12 past 1 would be PM, right? It would be 12:01 PM here, which would be the same day. But in America, 12 past 1, because the difference is 12 hours, right? And 12 past 1 would be the next day. So if it is 20 here, it would be 21 there. The difference is only of 1 minute, right? So to sort out that, obviously, wherever you have 12 hours difference, So for that you needed a line which would say half of the earth would be experiencing one day ahead and half of the earth one day before. So for that you can see the diagram here. 0 degree prime meridian is the main meridian from which all the time is calculated, and what they did is each degree of the longitude was divided. Okay, so each degree, or you can say 15 degrees of one longitude, is covering one distance, 1 hour of time. So if you're on the western side, so the time has to come, because the earth rotates from west to east, right? So on the east obviously the time has passed ahead, so you have to add time there. And when you go to the west, which means if you're on the west, you still have to experience the day. The one on the east have already passed the day. So where is the line exactly which decides which day has to be followed? Because the countries from India to America, so half of the countries will say I want to stick to the timetable of, I want to stick to the date schedule of India. Half of the countries will say America. So there has to be perfect line, right, which divides the earth in two halves, which says this half of the earth is experiencing the last day, next would be the old date, right? So here is the line. First is obviously the 1 degree prime meridian, which I told you guys, and second is the 180 degree, exactly opposite to it, behind it, and that line, that is the international date line, decides which day you are in. Okay, so as you can see here, and one more thing, if you notice here, you can see a zigzag like thing, right, where the 180 degree international date line is written. So if you see here, the right side line is the prime meridian, okay, which goes through Greenwich. That is the reason it is known as Greenwich Mean Time. Okay, it's in UK. Now on the left you see the international date line. You can see it in more of a zigzag way, right? The reason it is in the zigzag way is on the right hand side of the zigzag line, or the international date line, is Europe. The right hand side of the international date line is America, and on the left hand side you have Asia. So again, if the line was straight, the yellow country, or the time zone which you see, falls in Asia, but half of the country falls in the right hand side of the country, right? So how could a country be having two dates? That's not possible, right? So the line was cut so that exactly the right hand side was divided in America, maybe North America or South America, depending on where the country is, and left hand side came in Asia or Australia. Okay, so that is the reason why the international date line is set like that. And our world, okay, the whole of the world is divided in 12 time zones. Okay, so you have vertical lines, as you can see here, and these vertical lines, on the whole of vertical line, whichever country passes through, those countries have the same time on the vertical line. Okay, because it is east to west, it's not north to south, right? So this is how it works, and we are done with today's chapter. In the next chapter, obviously we will be seeing the earth's crust, and this time we don't have such dynamic concepts, so that would be relatively easy to understand. Thank you.
Hope you guys have enjoyed the video. Thank you.
Don't forget to click the subscribe button to be notified when I upload a video.